Guys, we're going to talk about the diagonals of parallelograms. I separated it into three rules. The first rule is called diagonals of parallelograms bisect each other. And that's one really cool thing that does happen when you have these diagonals, is that eventually they all end up bisecting each other and they all cross. So let's talk about the crossing of these bisectors. So the first thing you see here is if I had this side was 10, and these are bisectors now, JL and KM are bisectors. We have a 10, QL is going to be 10. The entire distance is going to be 20. If we have 7, it's 7 and 7. And then I'm going to show you some of the examples that they're going to come up with because of this rule. Because of this rule, the book is going to ask you to look for the lengths that are same in different parts and wholes. So if I give you the JL is 12, for instance, that means JQ is 6 and QL is 6. But what if there's an X? You have to go off to the side, you have to solve it. X equals 6. What about MK? What if MK is 20? If MK is 20, then MQ and QK are going to be 10 each. Now, let's say 7. If I told you the entire distance was 14, you would be able to say, and this was 7, then you would say it was 7 and 7. If this side was 10, now this is a really good example. If this little sliver of Q to M was 2x minus 1, and the entire distance of MK was 16, you have to find that other side QK. So it's 3x minus 1 as well. You can make 3x minus 1 plus 3x minus 1 equals 16. Someone else up in class, well, if the whole thing 16 isn't half of it 8 and 8, you have just done, and you can do 3x minus 1 is 8, and you get the exact same answer. So, next rule, alternate interior angles are congruent, and this is just a byproduct of doing these problems. So the byproduct is, we know that if we separated it from 75 and 105, we know the rules from yesterday, alternate angles are congruent. Now, what happened if that was 105 degrees? This left side, JMK is 100, but KML is not. It is 5. That means you have to do the alternate interior is going to be 100. So that one becomes 100, and this one, JKM, becomes 5 degrees. So, due to this rule, if you have x plus 5 over here, it's equal to the alternate interior angle, which is, in this case, 100. What happens is this third rule, which is each diagonal separates the parallelogram into two congruent triangles. And that is a big rule. That does come into play now. So if this angle is 64 and this is 25, what is this KJL? It's 64. And the other angle is going to be 25. That third rule comes into play because what is that missing angle up here? Well, you do 180 minus 64 minus 25, and that will give you 91. And that's 91 on both angles. So now we have two congruent triangles. So let's go over what congruent triangles are. So congruent triangles are congruent triangles. Each congruent triangle is all angles are congruent, and all the angles add up to 180, and all sides are congruent. Now, we practiced these. I tried this new software today, and I made an example. I said 35 and 35. I gave you JL as 70, and everyone was able to say 35 and 35. We use these whiteboards so you guys could try it out. Next, I gave you that this side is 15. I call it a sliver, but this portion is 15, M to Q. Forgive my lines, they're not perfect. This software, I'm still getting used to it. But if MQ is 15, what is QK? And that is going to be 15. And then what is the entire distance? You have to find here, in the entire distance, Gabriella got it right, it's 30.